Right, can we see okay? We can. Now, where do we want to start now for tutorial? Yeah, which page? 142. Okay, which question? The last one. Yeah, okay. 142, please. Question 3. Guys, what's wrong? What's all the chit chat about? What do we need? What do you need of here? You need what? Your book. Where's your book? Come on! Guys, come on, solve it, solve it. That's very kind of you. That's very kind of you. That's going to slam. No, okay. Right. So, page 142, question 3. Now, we have y equals 1 plus 9x over 8. Come on, 8 plus 4x. And I ask you to show that the derivative is positive. So, the derivative here is, quotient rule will do it, the bottom squared. The bottom times derivative of the top minus the top times derivative of the bottom. So that is 72 plus 36x minus 4 plus, is that right?
Oh, yes.
Maybe I made a mistake here. The bottom squared, bottom times derivative of the top minus the top. Oh, sorry, that's a plus there. Top times derivative of the bottom. So that's minus 4 minus 36x over 8 plus 4x squared. And that's equal to 68 over 8 plus 4x squared. And that's positive because 68 is positive. And yeah, 8 plus 4x squared is positive. Okay, so that's that first one there.
F in question 2.
Same page?
Yeah. No, E.
E?
Yes.
For real?
Yes.
That's easy.
Okay, then F.
No, I'll do E. I'm just joking. I'll do E. Okay. Can I scroll down? Can you see it there?
Oh, yeah.
Are you sure? Do you need to move?
No.
No?
Can you do a question on the implicit differentiation?
Yeah, just pick one out. I'll do, I'm doing another quotient rule now, though. Okay, can I scroll down? 2e sine x cos x over 3 e power minus 2x. That's a bit more convenient for me to write it like that.
Oh,
Yeah?
okay. Yeah.
Okay. Let's have a look. So I need the quotient rule. So the quotient rule is the bottom squared. The bottom times derivative of the top, which now requires the product rule. So that's sine's derivative is cos, so it's cos by cos, which is cos squared. And then it's sine by cos's derivative, which is minus sine. So it's minus sine squared. Minus the top times the derivative of the bottom. And the derivative of e to the minus 2x will be minus 6 e to the minus 2x. And the minus will flip that minus to a plus. And that's the answer for that one. Okay. When you're ready, you can give me the next one.
146.
146. Which one?
You do like question 5?
5, yep. Yep. Yeah. Can I scroll down? Five. X squared plus a half y squared plus 8y, yeah?
Plus 59 over 2
Okay,
equals 0
yeah.
at 1 comma minus 7.
Okay, so what I need to do here is differentiate. Derivative of x squared, 2x. A half y squared, y, dy dx. 8y, 8, dy dx equals 0. So that's y plus 8 dy dx equals minus 2x. So that's dy dx equals minus 2x over y plus 8. But x is 1. That's minus 2. But y is minus 7. So that's 1. So that's equal to minus 2. So the tangent is y equals m, which is minus 2, x plus c. Now I have to sub in this point. Minus 7 equals minus 2 plus c. So c is minus 5. Now I have my answer. Y equals minus 2x minus 5. Yeah. This is a typical exam question on implicit derivatives as well. You got a spare pen, Angela?
Yeah.
See who I've got. Is this 1 or 2? Which group is this? This is... Okay. Michelle, Abir, Autumn, Celine, Celine, okay. Sophia, yeah. Mubarak, Shira, Mohammed,
Yes.
Sabrina, no. Was she in earlier? No. Moza, Angela, Ahmed, Safra, yeah. Neil. Was she in earlier?
No.
No. Okay, so Neil and Sabrina then. Thank you. Okay. What's next? What's next?
What about the same page, question 12?
12.
No.
12. I did 12, didn't I? What do you need in 12?
I don't know.
Ah, no. Now you're just shooting the breeze with me.
No, not actually.
What? You have a particular question?
No, like I'm curious. Like I don't know how to do it, any of these.
Okay. D.
Yeah.
Yes.
Are you sure? I could have.
You did it with group 1.
And you're not group 1.
No.
And I suppose you want to see what they saw.
Yes.
Fine.
In real time.
Quality.
I don't know why. You know, isn't this supposed to be the stronger group? Isn't it? You know, the other group, they need more support. Now, don't tell them I said that, though, okay? All right. 12D. We have y equals sine inverse x. So the trick here with doing these ones is you have to put a sign on both sides. Okay, so sine of y on the left. Then what happens if you do sine inverse?
Cancel.
They cancel, so what are you left with? X. Now, let's implicit differentiate. So the derivative of sine? Cos y dy dx. And derivative of x? Of x? 1. So that means dy dx is equal to 1 over cos y. Yeah?
We have sine minus 1, so we can cancel.
Which one?
Yeah.
Oh, here? Yeah, because what I did was, just to be clear, I had y equals sine inverse x, and then I put sine on both sides. I added a sine here and here. So what happened was that and the sine minus 1 cancel, leaving me with just the x. Is that what you're asking me, or you're asking me something else?
No, because we have sine minus x is minus 1.
Yeah.
On this side, so we can cancel. Right?
We put sine minus 1 on both sides? We put sine on both sides. Yeah, so it's kind of the same thing, nearly. We're cancelling the sine minus 1 with a sine.
And
Yeah.
what's happened to the minus 1 in the y?
Here?
No, sine 1.
No minus 1 here, because what I did was, if you can see here, I wrote a sine here and a sine here. They cancel. On the left I have sine y, and on the right I have just x. Yeah. What's the problem with this answer I have here?
Cos y.
Yeah, but what's the problem with it?
This is dy dx.
Yeah.
Y should be an x.
Yeah, the y should be an x, shouldn't it?
Yeah.
We shouldn't have a y, we should have an x here. That's not as bad to fix as you think, because if you draw this, this represents a triangle. Y represents an angle. And sine is defined as opposite over hypotenuse. X over 1 can be represented here and here.
Yeah.
So this is square root 1 minus x squared. So what's cos y? Cos y is 1, this piece over 1. So it's just going to equal 1 over root 1 minus x squared. That's the answer.
Isn't it adjacent to the hypotenuse?
Yeah, adjacent over hypotenuse, which is this guy.
How do you know why it's the answer?
Because the sine inverse function always gives angles. You know, Celine, if you type in sine inverse 0.2, that's always going to give you an angle because of what the minus 1 does. Yeah. I've seen this in the exam maybe twice. They asked this question.
Can we do the exam questions?
Well, only if there's not questions from other people. That's fine with me.
Yeah, we're trying some questions.
Okay, is that how we feel? We'll look at some exam. Now we've done some exam questions on hypothesis testing.
Yeah.
Yeah.
Yeah, that's important.
Do we want to do exam questions on calculus?
Yes.
Yeah. Okay, let's have a look. Yeah, so if you like, we can open up Moodle on your phone. We're going to have a look at. Let's look at last year's exam. Bum, 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 bum. Where is 1718? 1718 version 1. No. That's why I said you can open it up on your phone. Let me have a look here. Da, da, da. No. Do you want to do a short one or a long one first for calculus? Short one. Because if I'm looking here, I'll just write on the screen which one. If you look at, of course, it's semester 2. 17, 18, version 1, A6. That's an E, that's like not too hard. It's a nice short one for 5 marks. Can you see it on your phone? Do you have it? Let's see. Now, the next one then after that is A8, which is an implicit differentiation. And then A10 is an integration with substitution. Then they're the short ones. Yeah, they're the short ones. Okay. Do you want to try it first and then see the answer? What are we thinking? Try it. So let's start with A6 then. That should take you maximum 5 minutes, but I actually think it should only take 2 or 3, especially if you have your calculator. So can you get it? Start that one now. We'll do this one. Are you working?
Yeah, I'm opening the A6, right?
Yes. Okay, how are we doing for this one? We got an answer? Yeah? So this one here, it was looking for the second derivative.
Yeah.
Okay, well the first derivative would be dy dx equals, what does log x become? 1 over x. And this guy? 2e2x. Now let's get the second derivative. So what will that become? That will become minus x power minus 2, and this one becomes minus 4e2x. And they ask you to sub in 0.3, so that's minus 0.3 minus 2 minus 4 e 0.6. And what do you get here?
Minus
399.
6.
Now they ask for 4 significant figures, so that would be what?
Minus 18.14.
Yeah. Yeah. It's not too bad, is it? And that's actually So, 5 marks. 5 marks. Now, what did I flag as the next one we could do? A8. A8. Yeah, A8 is an implicit derivative. It's 4 marks, so it should take you 4 minutes. But again, I think it might take you less. Okay, time to look at it. We got answers? We got answers? Yeah. Okay, so let's have a look. Cos x minus sine x, cos y minus sine y equals 0. Alright, what's the derivative of cos x? Minus sine x. Now this one here, be careful, it needs the product rule. So derivative of sine x, cos x, cos y, plus sine x, and derivative of cos y is minus sine y dy dx, minus cos y dy dx. That's equal to 0. So that's minus sine x, minus cos x, cos y, plus sine x, sine y, dy dx, minus cos y, dy dx, equals 0. Bracket, sine x, sine y, minus cos y, dy dx. And what I'll do is I'll take those two guys to the right. So that's sine x and then cos x, cos y. These two to the right. So then the last thing to do is just divide. Sine x, sine y minus cos y. Problem?
You can't put it into terms of x.
No. No.
How is it not a problem here? Because earlier we did sine inverse of x.
The difference is the question was what's the derivative, like I actually said what's the derivative of sine inverse x. I gave no reference to y.
Okay.
So the question was what's the derivative of sine inverse x.
Okay.
You couldn't really say 1 over cos y because there wasn't a y to begin with.
Okay.
We just put the y in to give us some guidance. Okay, I think we said number 10 next, which is an integration by substitution. So can you give number 10 a go now? Okay. Yeah. 8, you're looking for which question, is it? Yeah, it's number 10. 1718 version 1, I think, number 10. You have an answer, Angela? Shall we have a look at it now, or do you need another minute? We can look at it now? Yeah? Okay, let's have a look here. So, I want to integrate. Now, don't forget we have numbers here. 0 and 1. X cubed over 1 plus x4 cubed dx. Okay, and I think they actually tell you u is 1 plus x power 4. So that means du dx is 4x cubed. So that means dx is du over 4x cubed. So this becomes 0, 1, x cubed over u cubed du over 4x cubed. Cancel, cancel. This now becomes 1 over 4, integrate 0 to 1, u minus 3 du, which equals 1 over 4, u minus 2 over minus 2, 0 to 1. Now what do we do next? We do not put 1 and 0 in, because that 1 and that 0 are for x in the original question, not for u. So we need to convert it back. So that's minus 1 over 8, 1 plus x4, power minus 2, 0 and 1. Right, let's put 1 in first. If I put in 1, what will I get? I'll get minus 1 over 8, 2 power minus 2. And if I put in 0, I'll just get 1. So it looks like the answer will be 1 over 8, 1 minus a quarter. Which of course is 1 over 8 times 3 quarters. Which is 3 over 64. I think this is what it simplifies down to. Yeah.
I'm a little confused how you went from u to the power minus 3 to u minus 2 divided by minus 2.
Increase the power by 1, divide by the new power.
Oh, so you're just into...
Yeah.
3 over 32.
Oh, 3 over 32.
Yeah.
3 over 32, thank you. What about the Casio? So I know, and this is a little tip for the exam, you can integrate on this Casio. So if I type in integrate 0 to 1, fraction alpha x cubed over 1 plus alpha x power 4 cubed. I get the answer 0.09375. That's why in the question, can you see in the question where they say all workings must be shown? An answer, even the correct one, will receive no marks because you can get the answer directly. But it's worth checking your answer using the Casio anyways. Let's see what else is in this exam. Can you go down to the same exam, B for B for 5 marks? B for B for 5 marks. It's a quotient rule. Give that a try. got this one finished? No, not yet. We got it. This is taking a little bit of time. You have it, Angela? No, okay. It's a tough one, is it? Okay, I think you should be kind of finishing it by now. Yeah? Yeah? No? Anybody think they got the answer? Sophia? No? Celine? No? Mubarak? Nobody got this one. Alright, let's have a look. Celine, we're going to have a look at it now. Let's have a look. Who did? Autumn, you got it?
Yeah,
Alright. I have at least one good student, I guess. Okay. Y equals x squared minus 12 over x minus 4. And we want... Janira, do you mind closing the back door? It's a bit noisy there. I know, you have to really... Yeah.
Full power. Full power.
Okay, no, it's fine. It's fine. Done. Okay. Derivative. That's the bottom square. Oh, by the way, we absolutely know x can't be 4 before we do anything.
Yeah.
Okay. The bottom squared. The bottom times derivative of the top
Yes.
minus the top
Times 0.
times derivative of the bottom,
1.
which is 1. And that should equal 0.
Yes.
Now, the only way a fraction can equal 0 is if the top equals 0.
Oh.
So, we have 2x squared minus 8x minus x squared plus 12 has to equal 0. So that means x squared minus 8x plus 12 has to equal 0. So that means x, what have we got? 6 and 2? No. Yeah, minus 6 minus 2. So that means x equals 6 or x equals 2, and we should get the y values to go with that. If I put in 6, I get 36. 36 minus 12. What's that? 24. 24 over 4. Is it 6? Is that 6? If I put in 2. No, it's not 6. What is it? 12. Thank you. And what is the other one? 4. Thank you.
I was stuck at the...
Yeah, what the heck went wrong here? Yes, Sophia? Well,
I didn't... the numerator and equal it to 0.
what did you do?
Together with it. Yeah. The denominator.
But where did the denominator go? Did you move it?
Go to the right.
To be with 0?
Yeah.
I'm confused, but okay. Can you see now what to do?
Yes.
Yeah.
I was overthinking it. Thinking about, I think the modulus stuff yesterday.
Perhaps. Right, we'll just do one more today. The next one, C. 5C. And we'll finish on that. The short one. 5C. Got it done? Mm-hmm. B4. It's just the next one. 5C. Oh, sorry. I'm so sorry. Well, I hope that didn't I meant just literally the next one, 4C. Were you trying to do 5C?
No, I was doing the right one. He was like, no, this is 4.
Yeah, no, the chain rule. Yeah.
That's all.
Okie dokie. Shall we look at it now?
Yes.
Let's have a look. You are given y equals 3x squared minus 6x plus 5 power 8. And we want the derivative. What rule do we need here? Chain rule. Bring down the power, reduce the power by 1, and multiply by the inside derivative. And then, right? And then they say when x equals 1. So when x equals 1, this will be 0. Yeah? Did you get 0? It's obviously 0 because you have 6 minus 6.
Yeah.
Oh.
0 in total. It's not too bad. It's not too bad. Yeah.
We've been worried about the short entrances.
Well, have you been practicing the paper at home? How many questions do you think you've done so far? Huh?
Not that much.
Well, then you should be worried.
Yeah.
I mean, you need to consider yourself lucky because, like I said, most schools don't have the number of past papers you do. How many papers have you got? You've got A, B, C, D, E, F, G, H, I, J, K, L, M. And then I also have to upload 3 more. I have NOP as well. Okay? Most schools maybe might have 3 papers. Okay, but I've been keeping copies and reconstructing papers. If you get through all of these, you should basically ace the test. But it's up to you to manage your time, you know? Like, I could go into Moodle and I could see who has downloaded what, and it'll give me a good idea of how people are doing. But I don't want to do that because I think I might be horrified with what I see.